Okay, so we have here our following exercise. Okay, it's about the Bohr's atomic model, and consider the following energy levels of an hypothetical atom. Okay, and we have 4 different energies. Okay, so question A is about what is the wavelength of the photon needed to excite an electron from the energy of the first level to the energy of the 4th level. Okay, so remember, each level around the nucleus will have an energy, right? Okay, each orbit around the nucleus. Okay, remember this is an orbit. And about the atomic model of Bohr said that each electron around the nucleus will have like a floor on a building. Okay, so the energy, let's return to the question. Okay, the energy on the first level is about minus 15 by 10 to the minus 19 exponent, okay, on joules. And the energy on the 4th level will be minus 1 to the by 10 to the minus 19 joules. And remember, the energy that is negative is because we are talking about the bound state, okay? There is a bond between the electron and the nucleus. Okay, so first of all, the electron for jumped to the from level 1 to the level number 4, electron needs energy. Here appears the photon, right? Thanks to the photon that is coming here, the energy, or sorry, the electron acquires energy to jump to the 4th level, okay? So yeah, of course, the energy needed to jump from 1 to 4 is thanks to the energy that this photon gives to the electron to do the jump. Okay, so the difference on energy will be the final energy, that will be the energy on level number 4 minus the energy on level number 1. Okay, this change on the energy will be minus 1 by 10 to the minus 19 exponent minus again 15 by 10 to the minus 19 exponent. So this will be 14 by 10 to the minus 19 exponent, and that will be on joules, okay? And remember, you can do this on your calculator. So minus 1 by 10 to the minus 19 minus 15 by 10 to the minus 19 exponent, okay? And remember the scientific notation. This 14 by 10 to the minus 19 exponent will be the same, for example, 1.4 by 10 to the minus 18 exponent. Okay, those numbers will be the same. Okay, thanks to that scientific notation. Okay, that's it. This is the energy that the electron needs to jump from 1 to 4. Who will give it the energy necessary to do this jump? Yeah, the photon. Okay, so the energy of a photon will be the Planck's constant by the frequency of the photon. Oh yeah, of course. The energy of the photon will be 14 by 10 to the minus 19 exponent will be equal to the Planck's constant 6.626 by 10 to the minus 34 exponent by the frequency. Oh yeah, we can find the frequency. Dividing the energy and the Planck's constant. Okay. This will be the frequency. So 14 by 10 to the minus 19 exponent dividing by the Planck's constant. Okay, and remember, look at this. The calculator 14 by 10 to the minus 19 dividing by the Planck's constant. This button is very important, and the minus 34. Okay, so 2.11 by 10 to the minus, no, to the positive 15 exponent on hertz. Remember, hertz is the unit of the frequency, right? Okay, so there it is. I found the frequency of the photon that the electron is absorbing to do the jump. Okay, excellent. But that is not the question in your exercise. Your exercise is asking you the wavelength. Oh yeah, of course. The photon, this is the energy of the photon, but also this is the relationship between the wavelength and the frequency of a photon. Remember, photon is the particle of the light. So remember that the speed light, or the light speed, sorry, the speed of the light will be 3 by 10 to the 8 exponent, okay? This is the wavelength that the problem is asking me, and this will be the frequency, 2.11 by 10 to the 15 exponent. So we can clear here the frequency and answer the first question. This will be the wavelength. So it's going to be the light speed. So there will be 3 by 10 to the 8 exponent dividing by 2.11 by 10 to the 15 exponent. So of course this is a tiny number, 1.42 by 10 to the minus 7 meters. That will be the wavelength. And that's it. This is the answer of the first question. Okay, excellent. So back to the problem. What is the energy in joules that a photon must have in order to excite an electron from the second level of energy to the third one. Okay. The energy that a photon must have. Okay, so it will be the difference between energy on level number 3 minus the energy on level number 2. Okay, so this will be question B, the difference on the energy. The final energy will be 3 and the initial energy level will be 2. So the difference on the energy will be the energy on level number 3 minus 5 by 10 to the minus 19 exponent minus again 10 by 10 to the minus 19 exponent. So if we do the difference, that will be 5 by 10 to the minus 19 joules on the energy. And remember, yeah, if we are passing an electron from level number 2 to level number 3 is thanks to a photon, right? It's thanks to a photon that comes here, interact with the electron on level number 2, and the electron acquires that energy and jumps to the next level. Okay, excellent. So that will be the answer on question number 2. And question number 3 will be, let's see. Okay, so when an electron drops from the level number 3 to the level number 1, the atom is set to undergo emission. Calculate the wavelength of the photon emitted in this process. Okay. So it's the opposite way. Okay, from 3 to 1. Okay, so here I am on the third level, the second level, and the first level. And here the electron is going to the ground state. So if we pass an electron from the third level to the first one, a photon is emitted. Okay. So yeah, of course, we are talking about the energy conservation. The energy, the difference on the energies level will be the energy that will have the photon emitted. So passing from the third level to the first level will be the energy on the first level minus the energy on the third level. Remember that in physics and chemistry, this delta means the difference of two things. Always will be final minus initial. So final will be minus 15 by 10 to the minus 19 exponent minus again 5 by 10 to the minus 19 exponent. So if we do the subtraction here, we will have minus 10 by 10 to the minus 19 joules. Okay, look at this. This is important. This is very, very, very important. Okay. Again, this is very important. This minus over here we'll say, sorry, that we have here a photon emitted. Okay, that is important. Okay, that is the meaning of the subtraction of two different levels around the nucleus. Okay, this minus represents that the photon is emitted. And yeah, of course, the photon emitted will have this energy. Okay, that is important. Okay, now, if we want to calculate the frequency of this photon, okay, so energy will be the Planck's constant by the frequency. Okay, this energy will be positive. Why is going to be positive? Okay, it's a good question. This energy will be positive because I did the interpretation here that this energy is about the photon that is emitted. You will not need this minus to do this formula. Okay, yeah, maybe the question is why on the question A about this problem, I didn't care that this particular interpretation of that sign. Yeah, I did it, but I forgot to tell you that. Okay, here there is no problem because here the difference on the energy is positive. Okay, I will do the interpretation here about the positive sign on the difference of energy. Okay, that positive sign will mean that the photon is absorbed. Okay, oh yeah, but yeah, of course, because it's positive, here will not have we will not have a problem on the sign because it's positive. The problem is when the difference on the energy is negative, you cannot use it. Okay, and yeah, of course, it's thanks to the interpretation and the physics, because we cannot have a negative frequency. Okay, so 10 by 10 to the minus 19 dividing by 6.626 by 10 to the minus 34. Okay, and that will be the frequency of the photon emitted. So 10 by 10 to the minus 19 dividing by the constant, Planck's constant, sorry. Okay, there it is, 1.51. 1.51 by 10 to the 15 exponent, and that will be on hertz. Remember, that is a frequency. Okay, that is a frequency. And the last one will be that speed of light will be wavelength by the frequency. So the speed of light divided by the frequency will be the wavelength. 3 by 10 to the 8 exponent dividing by 1.51 by 10 to the 15 exponent. Okay, so the speed of light divided by the frequency. Yeah, this will be a tiny number and a small number, 1.98 by 10 to the -7 meters. And that will be the answer on question C about this problem. Okay. So remember, yeah, I know the difference on the energy from two different levels. The sign will have an interpretation. Yeah, photon emitted when the subtraction is negative, and a positive sign on the subtraction between two different levels will mean that the photon is absorbed. And that's it. That was the problem.